transformer, it transforms the source voltage. You see we have here VP and VS. So VP means the voltage in the primary. Primary means primary coil,
Yes, sir.
and this primary voltage is AC voltage. So AC voltage, when it goes anywhere, then it changes the direction, right? And
Yes, sir.
you got also that AC voltage is it has minimum to maximum value, right?
Yes, sir.
So it's changing the direction and it's changing the magnitude. So for this reason we are having changing magnetic field. We got the
Yes.
basic idea about electromagnetic induction. There we got electromagnetic induction occurs as there is changing magnetic field, right?
Yes.
Either we move the conductor wire, or we are moving the magnet, right? In both the cases there is magnetic field lines are cut by the wire, right? And there is changing magnetic field, we say this is changing magnetic field. So by this changing magnetic field we are having induced EMF. So if there is changing magnetic field over here, then these magnetic field lines are cut by the secondary coil, right? Here is written VS, that means secondary coil. So when we are having changing magnetic field in the primary, that magnetic field lines are producing induced EMF in the secondary. This is called transformer. Is it clear?
Sir, not fully. Like, I didn't understand what's the job. Like,
Yeah.
what does it do?
Like this one, the secondary, we don't have any current or any voltage, just is given the coil, right?
Yes.
The coil is given. So this coil is working like the coil we have in Faraday's law of induction.
Yeah, yes.
So what happens in Faraday's law of induction? We are moving the magnet, right? Isn't
Yes.
it? So we are moving the magnet towards or away from the coil, then we are getting induced EMF.
Yes.
Now what we are getting, we are not moving any magnet or moving any conductor, but by giving alternating voltage we are having the change in magnetic field, right? Automatically,
Yes.
right here. So this
Yes.
change in magnetic field is working like that one, that we are moving the magnet away or towards the coil, this one. Is
Yes.
it clear? So
Yes.
in this coil, secondary coil, we are getting induced EMF.
Yes, sir.
So this way we are having uh, transforming the voltage from one coil to another coil.
Sir, the laminated core is a magnet.
Laminated core is iron core.
Then what is the magnetic flux line?
Magnetic flux lines are produced due to this. This one is
Uh, yes,
creating magnetic field lines. If current is flowing through any conductor, then it's creating magnetic field lines, right?
yes, sir.
And that is magnetic flux. Magnetic field lines density is called magnetic flux.
And so
And
what is the load?
what is the load? Very
Yes,
good. Load is like any appliance. It can be one light, it can be one resistor, it can be any device. Like we want to get the output here, that's why it is called load. Okay, like it can be one
so
fan, it can be any device. Yeah, tell me then.
what is the job of the transformer? It reduces the
Okay,
voltage.
very good question. What is the job of transformer? Now we can give directly, we can directly give the voltage to any appliance, right? Now
Yes,
why we are doing this, that we are taking the voltage here, again we are creating here, then we are getting in the load. We could take it directly, right?
yes, sir.
So what is the purpose? Purpose is like we are required, for example, 5 volt, but our source voltage is 10 volt.
Yes,
Okay, so what we do, we give number of turns according to our need. We know one thing about induced EMF, that is the induced EMF depends on number of turns.
yes,
So if we have here like this side 20 turns, and
yes,
we are having 10 turns in the right side, that means secondary, then
yes,
if our source voltage is 10 volt, in our secondary or in our required voltage will get 5 volt. Is it clear
yes.
now?
Like how is that turns? Like it is not turning, or like the number of coil
Yeah, turns in
wrapped
the,
around it.
yeah, number of turns in
Oh,
the coil, that one I am
oh
saying
yes,
turns.
yes, sir.
Number of loops in the coil.
Yes, understood, sir.
Yeah, and vice versa, it can be increased and it can be decreased also, right? So
Yes,
if we want like 20 volt, then what we'll do, we will double the number of turns in the secondary.
yes,
Now it's clear to you?
yes, sir.
Okay, so I think your all the question came and I could answer your questions. Now you understood. Now we will go for some more information. The way I discussed, you will have the similar discussion here. The principle of operation. Can you read this part?
The transformer is based on Faraday's iron ring experiment. It transfers electrical energy supplied from the primary coil to the secondary coil by electromagnetic induction between two coils. At the primary coil, the applied alternating voltage sets up a changing magnetic field which induces an EMF in the secondary coil. As a setup transformer is one where the EMF in the secondary coil is greater than the EMF in the primary coil. Conversely, a step-down transformer is one where the EMF in the secondary coil is less than the EMF in the primary coil. It may be shown that
Yeah, Vs by Vp equals Ns by Np.
NP.
Okay, so
Yes, sir.
Vs is secondary output voltage, Vp is primary input voltage, Ns number of turns in the secondary, Np number of turns in the primary.
Yes.
So we have step down and step up transformer, right?
Yes, sir.
Okay, very good. Now you
Sir.
wrote the heading, right? After your heading is done, then you write this. You draw
Okay,
this
sir.
diagram first, and label everything. Here VP, VS, IP, IS, then NP, NS. These are most important thing here. Then you write here laminated iron
So do
core.
you have?
They wrote only core. You write laminated iron core. Okay.
Yes, sir.
And here
So
they
do you have electroscope in a syllabus?
electroscope. Actually, this one is in static electricity. Little bit. Uh,
Oh, okay.
you you have that is only for getting the presence of any charge, right?
Yes, sir.
That one is the purpose of electroscope. So have you started static electricity?
Yes, sir. It's finished.
It's done, right?
Yes, sir.
And from electricity, how many are done?
Like he finished static electricity, and now I guess he's going syllabus wise. Like
So before static electricity, we had topic 17, that is magnetism and electromagnetism. That one he did.
he did first static electricity, and now he's doing magnetism.
Okay, did he do that current electricity?
No, sir.
Okay, now he is doing magnetism.
Yes.
Fine. So he started with static electricity.
Yes.
Okay, fine. So your drawing is done.
Yes, sir.
If your drawing is done, then here you label some of the things I told. Laminated iron core you wrote, right?
Yes.
Then you beside VP you write in bracket, it's you write AC AC supply, huh? AC supply you write in bracket. AC you understand, right? Alternating current supply.
Yes, sir.
Okay. Then if you are done with that labeling, then you write from here at the primary. From here till here you write, huh?
Yes.
If you understand about step up transformer, then you can also understand step down, right?
Yes, sir.
That's why only write one, not needed to write both. Then you write this formula. Once you are done with this writing, you write this formula: Vs by Vp equals Ns by N. So are you done with writing?
No, sir. Yes, sir. Done.
Okay, so you have also wrote the formula, right?
Yes, sir.
Okay, so now we are having another thing that is you see here it's written VP, then IP, right? Then IS, VS. So in our practical electricity, you got one formula that is power equals voltage into current, right? Hello?
Yes, sir.
Yeah, so power equals voltage into current. Using that idea, we can get the formula here. Uh, Power in the primary equals VP IP, right? Isn't it?
Yes.
And power in the
Yes.
secondary is uh, VSIS, right? Power in the secondary is VSIS.
Yes.
Okay. So in both the coil, the power, we are giving the power input for a transformer which is 100% efficient. The power in the secondary will be also same. Okay. In the primary coil or primary, supply, we are having the power. In the secondary, we'll have the same power.
Like, why the same power? Like, if the voltage increases, then the power should also increase.
Yeah, very good question. That time what happens? Power remains same, but if your voltage is increasing, that time your current will decrease.
Yes.
Like if you have, for example, 100 watt uh, power in the
Mm.
primary, and your voltage is 20 volt and current is 5 ampere, right?
Yes.
Now in the secondary, if you want to increase the power, increase the voltage, like your voltage is 40 volt, okay,
Yes.
40 volt, then your current will be here 2.5 ampere. Is it clear now?
Yes.
So by using this principle, we also get some more benefits we are going to discuss now. You see the definition of transformer here given in the blue background, white color written. Can you read?
Yes. A transformer is a device that changes a high alternating voltage at lower current into a low alternating voltage at high current and vice versa.
So you understand
Yes, sir.
now, after discussion of this about the power, you can now get the idea, this definition, right?
Yes,
Isn't it? So you write this formula first. I'm writing the formula. Then you write the definition. First, you write this formula. Power in the primary and secondary
sir.
remains same. Okay. Yes. Anything, Iltin?
So what is the effect that alternating current produces that a direct current cannot produce?
Yeah. Yeah. Thank you for your question. Like, if we have direct current, then we cannot have changing magnetic field, which is mandatory to get induced EMF.
Yes,
So for this transformer, we need alternating current. Otherwise, we cannot get changing magnetic field. Then we cannot get any induced EMF in the secondary. Is it clear?
yes, sir.
So
So in the CIE syllabus, there is a chapter called electronic system. Is it the same as the introductory electronics in the book?
in your this book, we don't have electronics.
There is a chapter introductory electronics, like
Yeah, that
logic gates.
that topic that topic we have in Cambridge, right? In your
Yes,
book, do you have this topic, electronics? Do you have any discussion in this book?
like the cathode ray tube and the CRO
These are available
circuit,
in this book.
with some digital
Where,
logic circuit.
where, where, where it is
Chap
available?
24 chapter,
Hmm? Which page?
page 379.
379. Okay, what are there available? Cathode ray oscilloscope, then
Then properties of electron, then circuit components, resistor, LDR, digital logic circuit, and yes, maybe.
okay. So actually, introductory electronics, that part we need mostly. This one is having, we will discuss after finishing this electromagnetic induction. We will do those two topics. Okay. One is introductory electronics, another one is in electronic system. From electronic systems, we need only logic gate.
Okay.
Okay. Nothing more. So in introductory electronics, we start with thermionic emission. Uh, the way the cathode ray oscilloscope is working, and we have the structure and working principle of cathode ray oscilloscope. After that, we have like thermistor, then LDR, how they are working combined in potential divider circuit. You got the idea about potential divider, right? So that
Yes, sir.
one we are going to discuss. Then we have diode, we have relay circuit discussion over there. Then we have, you know, two different types of relay circuit. discussion. That's it. Introductory electronics, we don't have anything more than we have logic gates. Is it clear?
Yes, sir.
So we need maximum two classes to finish electronics.
Yes.
Okay. So power in the primary and secondary remains same. So VP IP equals VS IS, right? This one we
Yes.
can write. And if you know this, then you can rearrange also according to your need, like VP by VS equals IS by IP, right? We can write this way.
Yes.
VP IP equals VS IS. So we can write VP by VS equals IS by IP. So it's just uh, opposite of number of turns, right? In
Yes.
number of turns, you get Vs by Vp equals Ns by Np, but here you get Vp by Vs equals Is by Ip, right?
Yes.
So this way we get the working and calculations. Then you write this definition of transformer given. So sometimes this definition of transformer comes. That time you can write this definition. So done.
30 seconds. Done.
Okay. Okay. Now we are going to discuss one thing, that is transmission of electricity in grid lines. You write this heading: transmission of electricity in grid lines. So in our house, we are getting the electricity that's coming from power station, right?
Yes.
And it's coming from power station like wirelessly, or it's coming through some cables.
Cables.
Yeah. And it's like sometimes it happens hundreds of kilometers, right? Many kilometers is passing from one place to another, right? So when the electricity is passing through these cables, there is loss of energy due to in the form of heat, right? Due to friction of electrons in the cable,
yes,
and this is loss, right? And because
yes,
electrical energy is converting to thermal energy, and we are having, a small loss is a big loss, right? Together,
yes,
and this loss we can minimize, if we are giving 10 ampere current, the conductor will be more hot, right?
yes,
If we can give like 2 ampere current, then conductor will be less hot, isn't it?
yes,
Because the current flow is more, uh, that one will make the cable more hot. So if we have this, too much flow of current, then there is energy loss. One thing, there is other problems also, like due to too much heat, sometimes it may happen, the wire is becoming too hot, right? Or the
yes,
cable becoming too hot, then it may catch fire, right?
yes,
There is possibility. Or it's working for the wire which can work for maybe 2 years, because of this too much hot or temperature rise, its longevity will decrease, right? Maybe it will not go more than 6 months. It will break down, right?
yes,
It will be torn. Okay, so these are the laws, right?
yes,
If we have more current in the grid line. Now, if we can use the transformer, like step up transformer from the power station to the grid line,
yes,
uh, from power station grid line, if we are using step up transformer, then what will happen? The voltage will become bigger, right? And the current will
yes,
become less. So when the power station is supplying electricity to the grid lines, that time we are using step up transformer. Then when it comes again from the grid line to our house, we have step down transformer. Okay, so that we can have the voltage less. Okay, is it clear?
mm, like, mm, why can't we use such wires that can, like, they have the capacity to endure such high voltage?
Sorry, again, please.
Why can't we use such cables that have the capacity to endure such high voltage?
Okay, very good. Why can't we use the cable which can
Endure such high voltage?
current or voltage?
Yes, current.
Current. Okay, very good. So whatever the cable you are using, if you are using thicker cable,
Yes,
like if you are using thin cable, there is more possibility to have thermal energy, right? You can use thicker cable to carry that current, but thicker cable will be more expensive, right? And it will be more heavier to be, installing, or to be, hanging over the overhead or anywhere, is taking more space, right?
yes,
Or
sir.
it's more heavier than the pillars should be more stronger, right?
Yes,
Then also it is very expensive, right? Thicker one.
yes,
So that's why we have to also think about that one, so that we can make the cable with minimum cost. So is you got your answer?
yes, sir.
Okay. So look here, we have transmission of electrical power, right? You wrote, right? Transmission of electricity in grid lines. Have you written?
Yes, sir.
Okay. So you read this. Read this part. What is written here?
One of the problems in the transmission and distribution of electrical energy from the power station to the consuming load is the power loss as joule heating in the grid cables. These loss should be minimized for efficiency and economy. One solution is to have very thick cables so that the resistance R is low. Then the power loss as heat in the cables will be minimum. However, there is a limit to the extent to which this can be done. The thicker the cable used, the heavier is the weight to be supported, and hence the higher the construction cost.
So
Another solution,
okay. Yeah. Then hmm. Yes. Read.
another solution is to reduce the current in transfer. This can be done by using transformers to set up the voltage at which electrical power is to be transmitted. Suppose the electrical power output P out is to be delivered at the potential difference of V by the supply lines of total resistance R. Then the current I in the supply will be I equals to P out by V. Hence the power loss as heat P loss will be given like this. Thus the greater the value of V, the lower the power loss. Hence the electrical power can be transmitted more economically at high voltage and low current. Low voltage transmission is not used due to the continuous heat loss and faster wearing of the insulation. On the other hand, a higher voltage would raise the cost of insulation. Hence, for the most economical transmission of electrical power, one must consider all the factors such as cable resistance, the voltage of transfer, and insulation cost.
So it's clear, right?
Yes,
So you write this. What is written here in the blue color? A high voltage is used in electrical power transmission to reduce power loss. Okay, have you understood all these things?
yes, sir.
Okay, now we are having a 10 minutes break. Huh? We'll start 6:37. Okay.
Okay, sir.
Hello.
Yes, sir.
Okay. Come back 6:37.